Thanks for joining this Tech Talk on actionable alerting with Splunk infrastructure monitoring. My name is Janelle Shaw. I'm a staff sales engineer with Splunk, and I'm focused on observability. In today's session, we're going to look at intelligently detecting issues with actionable alerting. And what that really means is we're going to look at how to set up accurate alerts using data science algorithms to avoid the alert noise. And we'll use Splunk infrastructure monitoring. You'll see a demo, and not just of defining the alert triggers, but how to also integrate with notification and automation workflows. So this is the goal. Why we have this tech talk is because no matter what organization and across different roles, users, customers are looking for ways to intelligently detect issues. And that might be an anomaly, that might be errors, it might be utilization of resources, underlying resources in the infrastructure, and you want to make sure you identify before you run out of capacity. Or maybe you want to identify to spin up additional resources. And the ask from organizations has been, do this in a way that minimizes the noise. We don't want to be flooded with alerts. So there's got to be a way to use data science or other smarter type of detection mechanisms. A lot of organizations also ask a way to manage this programmatically. So we're going to use the user interface today, but I'll point out areas where you could absolutely manage this as code. Then, of course, the other thing is integrate with notifications automation and not necessarily having someone watching the screen to turn yellow or red. So we want to be able to route that in an automated way. With Splunk infrastructure monitoring, the terminology that we use is detectors. So detectors are the feature, the capability that provides that mechanism to detect a certain criteria. So it's not just a static threshold. I'll show you a number of intelligent conditions, again, data science algorithms that are going to ensure that you detect an issue without being too noisy. We don't want to flood you with alerts. So I'm going to show you, I think you'll be really impressed, the capabilities here. And then alert is when that trigger event actually happens, right? When we meet the condition, not only do you maybe want to indicate that on a dashboard with changing from green to yellow or red, but you likely want to route that to an expert. You want to make that actionable so someone can intervene or take action. And so we'll look at notification systems as well as ways that you could trigger automation. So we have a number of integrations, not just with the Splunk portfolio, with Splunk partners as well. And it's very common to trigger something like maybe a rollback or some other action using automation. So in the demo, again, we're going to look at how you can enable actionable alerting. We're going to look specifically at the capabilities to minimize the noise. I'm going to walk you through those data science algorithms that we have available. And then we'll enable that notification and automation so you can see exactly how simple this is to get started. So let's take a look in Splunk infrastructure monitoring. So let's start logically in this tech talk in the alert panel. I want to start here. This is going to be the result of defining your detectors. And what you see here, we're on the active alerts page and it's showing just that. But what I wanted to call out was the ability to filter very easily. So if you want to get a sense of what are the most severe, the P1s, the critical severity, you see it as applying a filter here. But you can also filter by different severity just by clicking on the dot. As you set up detectors, you may choose to even have things that are informational only, so they don't go into a P1 type of a queue. They don't trigger notification, so you do have that severity control, which is a very nice option as you're getting started with detectors. I'll display all. The other thing is you might use different tags that are part of the data and the detector itself. So maybe you want to understand which of those are part of this particular AWS region. Maybe you're only responsible for one of the EU regions, for instance. So this is a great way to be able to see where those critical alerts are occurring. Another is to assign team ownership. So as you define a detector, you can link it to your team. And that way we could see if any of these apply to, this is me, Team Shaw, and Team Shaw does not actually have any active alerts. So this is another way to be able to verify what's in your queue versus what might be in the larger inbox. The detectors page is what shows what is actually defined. So the detector is that criteria definition. And you notice it is also showing whether your detector is in an active state. So you can see that information right from here, which is very useful. I define most of my detectors for my demos just with my name at the front. So that way, when we're in an environment that's shared like this, it's easy to identify. So a good naming standard is very helpful. And I'll show you that throughout the product as to why it'll be helpful to know the prefix for your detector. Here you see I have two that are defined. Neither of those are active at the moment. From here is also where if they were active or if I knew I wanted to mute any sort of notifications, we can do that as well over here. Create a muting rule for this and it would match that criteria, manage subscriptions and permissions and so forth, link to the team like I mentioned. Now, where can you get started? We're going to actually create the alerts from a chart starting point. That's always the best place to start. But there is, I want to make you aware, there is this templates view. They are not defined with Janelle. Here's the templates view. And if you are looking for kind of that blanket starting point, just like it sounds, a template, let's say you're collecting CloudWatch data and you wanted to get a starting point on CPU utilization and defining a detector for that, you see, here's one for greater than historical norm, greater than the normal population. And of course, we have lower CPU utilization, that same type of comparison, or just a generally high CPU utilization. When you click on any one of these, being that it's a template, it already has the alert rule pre-configured for you, but it explains the details of that alert condition. So for CPU utilization, it's looking for in the last 10 minutes, it's more than 3 standard deviations above the mean of its preceding 24 hours. So that is a great starting point. See how accurate that is. You can put parameters around that. So maybe we don't, again, want that applied to everything. Maybe you have it set up in your definition for CloudWatch, you have multiple account IDs. So you want to have it applied to just one account ID, or you have other parameters, right? You want it to be just certain host names or whatever that metadata filter might be. So you can set the definition here for those parameters. And then current recipients means what should it do? What is the notification mechanism? It doesn't necessarily have to be a person. It might be a target system, but whatever you enable from an integration perspective, whether you have integrations into, for instance, we use Slack internally at Splunk, maybe you're using VictorOps, our on-call solution. So that way you can route directly to someone's mobile. Teams, maybe you want to open an incident in Jira, webhook functionality. So very easy to add one or more mechanisms, trigger mechanisms here, and then simply activate it. So that's another great starting point. And then this is also where you would be able to access the muting rules. So once you define rules, you would see those from here. So let's go ahead and create a new detector. And I'm going to open a dashboard. I have that here already. Again, just from the dashboard menu, pretty simple. This one is a custom dashboard. So I copied some charts from the pre-built content, and you'll notice up here, it doesn't say read only. So just be aware there are differences, of course, between write and read only. You'll see as you click into any of the charts, there is this bell icon. So there's different places you'll be able to create a detector. This is one of the most obvious here. You'll see the bell icon. When you click on that, you can link to an existing detector that you've already defined, or you can create new right from here. You can create new, ask for a name. I recommend a naming standard, so they're easy to find and sort by. When you click into here, you'll see the different signals that are fueling this chart. So here's our different inputs and whether or not it's being plotted on this chart. We have, right, percentiles, min, max, and so forth. I'm going to take this off because if you notice, it's only actually the maximum that the condition is going to be set to. You can change this as well. So you could use this chart and say, oh, I want to alert, based on whatever swim lane, whatever analytics you have here, that function. I want it to be on the max though. So I'm going to apply that. I want to show that as the only one on the graph while I'm doing this validation. Then you can use this menu here, proceed to the alert condition, or you can click over here to get to the next step. Now, this is where we have so much flexibility. When we talk about data science, this is what we're referring to. So static threshold, been around for years, pretty straightforward. So let's go to something more interesting. A heartbeat check is when a signal has stopped reporting for X amount of time. This is a great way, right? I want to know when something does not exist, when I don't see CPU utilization, for instance, for a particular service or a particular host. Resource running out. This is good from a forecasting perspective. Detect when a signal is going to reach a min or a max. So when it's going to reach capacity or it's going to drop down to 0 based on the trend. So you can define the parameters around that. Outlier detection is ideal for a group of instances that you expect to behave similarly. So it might be a group of load balancers or web servers or web front ends or microservices or Kubernetes nodes. So when we have more than one, and I want to know if, say, CPU utilization is unusual for one of the members of that group, this is a great way to be able to detect that outlier. Sudden change, just like it sounds, when the signal is different from normal behavior, and then you can put controls around that, like it has to be different by at least X number of standard deviations over the last 12 minutes. So you put controls around what sudden change means so that you're sure it is a sustained true sudden change. Historical anomaly is when the signal differs by a specified amount, again, having those controls, so it's a sustained difference, but it is comparing it to that previous same period. So it's a great way, almost like an advanced type of a baseline. And then custom threshold is ideal if you want to have maybe two conditions at the same time. So when this goes up and that goes up, or when this goes up and that goes down. So you can have multiple conditions, compound conditions, and that's where custom threshold is very helpful. Now, even though we would probably use, so CPU utilization, probably use something like a sudden change, or since it's only one that I'm looking at the moment here, we have it set to the max for that cluster. We could go back and have it actually show us the different instances for CPU. So if we went back to the signal, instead of having it show just the max, we could actually have it show the max for the individual hosts. So you can click on max, and we wanted to do it for the unique AWS IDs, and notice it changed it in the stream. So now we see the different, if you notice what I'm hovering over, it's showing the different AWS IDs. So whether you want to do it on an average across the group, or you want to do it in this case for all the different EC2s that we're monitoring CPU for, no right or wrong way, just depends on what you're trying to detect. Now, when we do it this way, I'll set the condition. And if I pick something like outlier, in this case, what I want to get to is when you go to the alert settings, this is where you have control over the sensitivity. So are you watching for a breach above, a breach below? Or do you want it to be pretty sensitive? Do you want to adjust that trigger sensitivity, as well as the actual settings behind the scenes? So by default, you see it set looking for deviations from normal. And here's the conditions around that when it will trigger. How long a trigger has to be sustained, right? What's the duration? It doesn't have to be deviations. You could do percentage of change. And what's happening is, as I change around the settings, it's preparing a preview up here at the top. So when I click start, it's looking to see would this have triggered. Now, if you're setting this fresh, right, this is looking at the last 15 minutes. So you can say, well, I want to look for the past hour, compare it to more data, or you can roll back to longer than that and then click a preview here. Now, this is helpful because I want to make sure this is not alerting all the time. So if we look at the condition, and I even select something like threshold just to prove the point here, if I'm watching for this condition, and these are mostly around 19 variants, so I'll say maybe 19.55, look what's going to happen. This would have triggered, and obviously I did this purposely to show, this would have triggered a phenomenal number of times in the past hour. This is a bad setting, but this is a great way to validate that. So before this goes in production, make sure it will, how often will it trigger? So think about this. If you had an issue, let's say this morning, there was an issue and I want to roll back to the last 12 hours in this preview, I can validate that this would have caught that breach. So this is how you make sure that whatever problem you just had that now you're going back to set your alert for, this is how you make sure, yeah, it would have matched that condition. This is also how we can make sure that this will not be so chatty. Maybe I change it to 0.7. It's going to rerun now, and we'll see what that chattiness looks like. Not significantly less, but it's still breaching quite often. So this is how you make sure you're choosing a logical condition, because again, maybe it's not just static threshold. Although I wanted to show you something else. Even in the static threshold, I'm going to take this out. There's not, you can do more than just above and below. You can actually put in a range. So this can be helpful as well. So even though static threshold is not my first choice, it is more intelligent than just a traditional single value that you're comparing against. We could put in a range here, and validate whether the signal stays in that range or goes outside of that range. So you even have more intelligence around things like static threshold. Now, the other thing you can do from here is define the alert message. Actually, let's put it back to something nicer here. Let's do sudden change. And now it's going to do the preview again, right? I'll leave it on low. Let it run. We're going to go to the alert message. I showed at the beginning the severity. This is where you would change the severity. So not everything has to be considered critical. You might want to change it to informational or warning, especially depending on the stakeholders that you intend to have notified. So you would change that here. Runbook. This is a great place to put in a link to whatever that might be Confluence article or some other knowledge source, right? Is it, where do you host your run books? Is there any sort of automation or something that you want them to follow? Wherever that lives, obviously you could put the URL in here. You could also give information from a tip perspective here. Customizing the message is pretty flexible as well. So you see there's keywords like the detector ID. You'll see also the actual severity details and anything else that we're populating here. So every time this triggers, there'll be an incident ID associated with it. So you can track it, not just here, but if you're pushing it into other external incident and issue management systems. So you have a lot of different keywords that you can choose from as I scroll over here. So you can modify this using the editor right here. Recipients is a notification perspective most commonly. So when I add recipient, not very much enabled in this environment. This of course would email me. That's who's running this demo. You could send an email to anyone though, doesn't have to be a user. So I'll just send it to myself so I don't bug anybody else with my demo, but you can send an email to a non-stakeholder and they can get a notification that way. Non-stakeholder in the tool, I mean. Team would be the team here within the UI. Slack is what we often use internally for direct messaging and using Slack channels. So I could route this to a particular Slack channel like Team Shaw on call. So that way they'll be notified in a way that's friendly for that particular team. And webhook could be anything from, integrating to another system. It could be sending an incident into even another piece of the Splunk portfolio. Now, there's a number of other integrations, and I'm going to pause here for 1 second just to show you. If we come back out here into the data setup and specifically look at the notification services, some of the other ones that you're going to find useful, of course, are, you see right here, things like Jira. So we support both Jira Cloud and Jira Server. So after you enable that integration, it can trigger an alert and it sends, creates an issue in Jira. Microsoft Teams is another popular one that comes up. This will, of course, send a notification to a Teams channel. ServiceNow is another integration where you're a ServiceNow customer as well. So you could actually have multiple for any of these. So when you set it up, you could actually have multiple integration points. So it's not like you set it up once and that's it. Like this is the Slack channel for our app dev team, but we could add an integration to another team as well, or another channel and so forth, another workspace. In the case of Slack, it would be another workspace, but you can do that across anything. So maybe in ServiceNow, you want to route some of your alerts as an incident and some of them as a problem, and you have different teams and so forth that associated with that. So for any of these integration types, absolutely you can create multiple integrations there. So if I come back to my detector, go ahead, proceed to that activation, and then anything that you want to customize in the actual name, you can do that here as well. We'll activate that guy. So there we see it visually. Remember, we started this from a chart. Go ahead and a couple things you could do. Remember we talked, I mentioned signal flow, programmatic. We have some other tech talks on that, but this is where we'd be able to see what does the signal flow look like. So anyone that's interested in programmatic management of your infrastructure monitoring, signal flow is at the heart of that. And as you can see, this is a Python-like language. So what we've defined, we're looking at this particular data input, right? It's the CPU utilization on EC2s. And then again, these were the different swim lanes. So we had the built-in functions that we were using against that for the percentiles, min, max, and so forth. And then the detector condition is pretty straightforward here as well. So this can be used to programmatically define the detector. It can be used for the charts, the dashboards, the detectors. You can also plug that into Terraform, and that way you can very easily create charts, detectors, dashboards, programmatically manage those through code. So you would see that from here. I'll go ahead and click save. Close out of here. Now we come back to the dashboard. Because we started from here and because this is a dashboard I have write permissions to, you can see it actually outlined here. And this is a phenomenal way to be able to give guidance to your user, to the consumer of your dashboard. And just a difference here, if I go over to one of my other dashboards. So this one is showing for AWS load balancers, ELBs. Well, nothing in particular, right? I'm looking at some of the data here, and obviously these are small little demo environments. But if we simply link to an existing detector that you've already created, again, maybe using templates or so forth. So we have one that's already defined. So somebody has a condition watching for unhealthy hosts. When you add that in, all that actually is doing here is adding another row, right? You can see another lane, and we're showing, yes, we want to visualize that. You could also link to detectors this way. So you could search for them just like you do for a metric that you want to add to a chart. You can do that as well. Then when you save and close this, now we have it on the view, and wow, now it's so much more intuitive because we know that's a problem. So that's a big deal. The other thing you can do then is from an overlay perspective, and you can have this saved off. So this is why the naming convention becomes so important. If we know the name of that type of event, or in this case, the type of detector, unhealthy host detector, you can see it there on the chart name as well. If I select that and say show events, it'll show it over here. We see it went off 42 minutes ago. You can save that as part of my dashboard variables. And even though this one is a single value, we see it graphed down here as well, overlaid here. So we can see this is when we moved into that unhealthy host state and when the detector would have triggered into an alert. So you can actually click in and see the alert detail here. So for anything that you're defining a detector for, you will have this alert report here. It'll give you any of the details and any of the links that you might have defined for that configuration here. So again, a great asset to have, be able to lay those breadcrumbs for the user. So let's see what it would look like to receive a notification like we set up. So I have another similar detector, Janelle's CPU percentage detector. So if we come over to the Slack channel here, we were sending it to Team Shaw on call in the example. And so we have that Slack channel open here, and you can see what that would look like based on that definition, the alert message that you defined. Here's another example of an alert notification, but notice this one's green. So you can also send for the clear event. So obviously the anomalous event value is anomalous, and then whenever the value is cleared. If we look over here in, say, Splunk, we can do a search. So we could search for events for CPU percentage detector, and we run that search. This actually is using the Splunk infrastructure monitoring add-on. And that way you can query for your events like alerts, you can query metrics, you can put everything you want on your existing Splunk dashboards if you already have views built out there, or if you're already using something like IT service intelligence for your event analytics. So absolutely, that is still a great option and a recommended point for consolidation. And this is just so you can see the payload that's available. So whatever target you're sending into, whether again, it might be going into like a ServiceNow or something directly, you'll see a lot of that metadata there. Even things like if you set up that run book link or a tooltip, or the condition, whether it's returning to normal or it's the initial trigger event. So it'll show it as anomalous, and it'll give the details for the value as to what triggered, right? We had the threshold set in this example, it's set at 19.55, and this is what the actual value was. So this is another great way just to see what that would have looked like. So I've just opened up another view here, and we use this sometimes in demos, so you may have seen this before, but what I want you to see is the effect that the detectors can have in your environment. So this one is showing for a catalog service, it's showing requests per container. So you can see there's 3 different containers. And when you have an event in the environment, like we were just looking at, so a canary push in this case, and there is something going wrong, right? We want to detect that anomalous behavior. what I want you to see is the speed at which the detection can happen. So if you notice, these are actually updating at 1 second. And so the canary push happens, the response time started to go through the roof, breaching our SLA. And it is happening, if you notice here on the left, we tore down one of the current production containers, spun up the canary code, and it was problematic. So whatever type of a change in that environment it might be, whether it's canary code or it's a configuration update of some sort, something in the infrastructure, even a business event, you see very quickly we're able to detect that anomaly is occurring before. You're not waiting a minute, you're not waiting 5 minutes. This is happening very quickly. And this is using one of those data science driven detection mechanisms, latency outlier. And then in this case, it's actually triggering an automated rollback. So think about that in your environment. And if I drill in here so you can really see the power of the speed, what that really means. So here, that canary event takes place, 14:11:38. We start to see, this is latency that we're looking at. Start to see latency increase right away. And then that detection, that outlier detection is at 14:11:48. So 14:11:38 to 14:11:48, we detect that this is a problem. It is not like the others. And then triggering some sort of, in this case, a rollback. And this is validation that that rollback happened. But do you see how quickly at 14:12:09, if you wait too long to even detect the event, then you wait even longer to trigger, right? There's implications around the mean time to acknowledge and to start to remediate. So when you think of automation, this is another reason why a streaming analytics platform and what real time really means. And again, 10 seconds is typically our standard view, but high resolution, 1 second, absolutely important as you move into more advanced detection type of conditions like we've been looking at today, as well as when you want to introduce automation. So I obviously have a terminal open. I want to show you what's in this directory, Terraform scripts. So programmatic management of your monitoring. Let me open up one of these. So what do you need to interact? Well, of course, you're going to need an access token, and the realm, in this case, US1, that's one of the most common realms we use here in the US. This is simply going to create different detectors, dashboards, and so forth, and it's going to use that Splunk_IM prefix here. So close out of here. Let me show you exactly what it's going to do. So if we look under modules, AWS, for instance, there is one for ECS as an example. So we open this up. This is, I mentioned signal flow earlier. This is using the signal flow, that Python-like language behind the scenes. So there's the definition of the signal inputs and any of those functions, calculations that you are applying. This is the condition, right? When is it going to detect? What are the criteria for that? And then of course you have the resource name, description, severity, and so forth. So you can do this programmatically. So this is a great way to be able to manage your environment. And if I run this, I'll say yes. And as you can see, it's actually creating a number of dashboards. It's creating detectors. So imagine if you are someone on the infrastructure side or on the cloud ops team, and you deliver this to your end users as a service. When I come over here to detectors, I'm going to refresh this. Look at this. So we just created all these different detectors. And again, you saw this is the prefix Splunk_IM that you saw in the script for the Terraform script. So imagine having kind of your templates, not just our standard templates, but having your own template defined. And then you could prefix this with either an environment or maybe your team names. And that way each team could have their own individualized experience, but you could be starting from a gold image. So this is a great way to be able to manage that. And then you can check in your Terraform scripts, of course, as code, part of your overall CI/CD process. And you can just as easily tear them down as well. So it's, being able to create, manage, and remove as appropriate. So I'd like to share some additional resources as you continue your Splunk journey. We have online free training. So you see a link to the SigmaFX Fundamentals series. Also, of course, documentation. That's a great place to learn more about detectors and alerts. And then I also have a link here to a blog post. And this one is talking specifically about compound conditions. So often we set the trigger for, the detector trigger for a single type of a condition, but compound conditions have a great role. And so I want you to take a look at that as well. Thanks for joining.